All right. Hello, everybody. Good afternoon or good morning, depending on where you're joining from, and welcome to today's webinar. We're excited to have you all here for today's discussion, which is going to center on new guidance available from the Federal Highway Administration that's intended to help agencies assess safety risks for pedestrians and bicyclists. Our presentation today is going to focus on how agencies can use this new guidance to understand safety risks and improve safety for non-motorized road users. The webinar today is supported by the Federal Highway Administration's Office of Safety through a program led by VHB and the UNC Highway Safety Research Center that provides training and technical assistance to the FHWA designated pedestrian and bicyclist focus cities and states. My name is Dan Jaleen, and I will be facilitating today's webinar. I would like to take a moment and introduce you to each of the panelists that will be joining us today, all of whom were involved in the development of FHWA's guide for scalable risk assessment methods for pedestrians and bicyclists. Of course, we have Tamara Redmond with us here from the Office of Safety. Tamara led the program, the development of this resource from the FHWA Office of Safety, and also leads the FHWA Focus Cities and States program, among many others at FHWA. Sean Turner is here. He's a senior research engineer at the Texas A&M Transportation Institute, where he's conducted applied research for over 26 years. Sean's focus in pedestrian and bicyclist transportation includes usage monitoring, data collection, and quality assurance, planning methods and tools, and safety and behavioral evaluations. Also with us today is Dr. Ipek Shener, who is an associate research scientist at the Texas A&M Transportation Institute, with a main research focus on travel demand modeling and activity travel behavior analysis. Ipek has a particular interest in transportation-based health research and studying alternative modes of transportation. He's also dedicated to exploring emerging technology-enabled mobility options and how to better integrate them in a safe, sustainable, and equitable travel environment. Michael Martin is with us today as well. He is a research scientist also at the Texas A&M Transportation Institute, where he conducts multimodal transportation planning and safety-related studies in both urban and rural contexts. His work has focused on providing communities and local, state, and federal transportation agencies with data-driven results that are informative and implementable. Dr. Robert Hampshire is here as well. He is an associate professor of public policy at the University of Michigan's Ford School, a research associate professor in both the Transportation Research Institute's Human Factors Group and Michigan Institutes for Data Science. His research focuses on management and policy analysis for pedestrian and bicycle safety, as well as emerging innovative mobility services. We are really grateful to have such an excellent group of panelists with us today to share the results of their work and talk about how agencies, you all in the crowd here, can learn from it and use it. I have a few things I want to cover before we get into that, the main presentation today, and it's mainly housekeeping items. I want to encourage you, if you have problems with your audio or problems with your connection, to please either rejoin the session or call back in. You also have the option to switch between telephone and your computer mic and speakers, and so hopefully toggling between those options will help solve any problems that may come up. You won't be able to speak, unfortunately, during the webinar because we have such a large group today, but you will have the ability to send your questions and your comments into me using the questions pod located in the GoToWebinar control panel. You can send those in at any time. I'll try to respond to them as they come in if I can. If not, what we're going to do is be holding around 20-25 minutes or so at the end of the presentation so that we can ask the panelists to respond to all of your questions. We've got a webinar archive page set up for this session. I'm going to be sending the link out to you all in just a moment. The archive page has a few things posted on it. One, it's got a PDF copy of the presentations that are going to be shared today, so don't feel that you need to write everything down. It's also got a link to a few helpful resources. One is the guide we'll be talking about today. Another is an Excel tool that goes along with the guide that we'll also be describing in some detail during the webinar today. All of this information, including a link to the archive page, will come to you later today in an email, a follow-up email that will come about an hour after the session. It'll have that information I just described, the archive material, further resources, as well as instructions for downloading a certificate of attendance for the webinar. So it's important to know that if you're attending this webinar with multiple people at your site, please forward that email to each of them as well so that they can also generate their own certificates of attendance. If you want to learn more about PBIC webinars that are coming up, we have quite a few left this month even. A lot of them posted on our website now, pedbikeinfo.com. webinars. You can follow us on social media, sign up for our mailing list. There's a lot of cool stuff happening right now with webinars, and we'd encourage you to attend some of those sessions as well. One thing I forgot to mention is that this webinar was submitted to the American Planning Association for consideration for 1.5 CM credits. So if you're a planner and you're used to logging those credits, please visit the AICP or the APA website and their event calendar, and you should be able to log them there. Before I move on and continue with the presentations, I would like to take one quick poll of the audience. We usually take this poll to find out how many people are out there today. So we'd appreciate any time you can spend casting your vote in this poll. It might just be you, and if it is, welcome. We're glad you're here. You might have a small group with you. Just let us know about how many people are attending from your site today. We're going to keep this open for just a little bit longer, and then we'll move right into our presentation. All right, I'm going to leave it open for just a few more seconds, let you get those final votes in. We do appreciate all your feedback and taking time to weigh in on this. I'm going to go ahead and close the poll now. Thank you all very much for voting. And I'm going to turn the screen over for our presentation today. So Sean, keep an eye on your screen, and I'll let you know when it comes up and when I can see it. And what I'd like to do first is hand things over to Tamara Redmond from the FHWA Office of Safety to talk a little bit about this resource and help introduce the panel today. So Tamara, whenever you're ready.
Okay, thanks, Dan. So the primary objective of this project was to develop an approach to estimate pedestrian and bicyclist risk at several different geographic scales. Inherent in estimating risk is exposure, which is a measure of the number of potential opportunities for a crash to occur. The need for better exposure data was very influential in the origin of this project, and it's important to note that we didn't develop a brand new approach from scratch. Instead, we tried to make it easier for practitioners to conduct risk assessments and estimate exposure for pedestrians and bicyclists. And we do this by showing how the pieces of the puzzle fit together in a certain sequence. And we're trying to highlight best practices and lessons learned for more quickly putting the puzzle pieces together. And also, we've documented numerous risk assessments in a synthesis that was published last year, and it's available online. And that's going to be in the email that Dan sends you following the webinar. Next slide. So there's several different objectives for this webinar. The first is to outline the 8 steps in scalable risk assessment for pedestrians and bicyclists. The second is to describe how exposure is included in the 3 ways to quantify risk. And the third is to describe the 4 geographic scales and how scale influences the selection of exposure estimation methods and exposure measures. And now I'm going to turn it over to
Thank you, Tamara. Hi, everyone. This is Sean Turner from TTI. I'm glad you're able to join us today. So we have 4 presenters in our webinar today. You've already heard the names. So I'm going to be giving an overview of the basic steps within the scalable risk methods. A key part of risk is quantifying exposure, and so I'm going to be talking about exposure from counts. Ipek Shinar is going to be talking about estimating exposure from demand models. Then Michael Martin's going to talk about estimating exposure using travel surveys. Then finally, Robert Hampshire from University of Michigan is going to present a case study example that shows how the methods have been applied in a pilot test in Michigan. So in a 90-minute webinar covering such a broad range of applications, it really is hard to get into the details, but I hope that today we're going to at least pique your interest and that you'll follow up and check out the guide and the other resources on Federal Highway's website. So to get started, we've outlined these 8 steps for risk assessment. So these 8 steps provide a general framework to follow, but also allow flexibility in choosing different measures and different methods for different contexts. There's a reason why scalable is the first word in this project title, and that's because scale matters. It matters a lot. The desired geographic scale is going to point you down a certain path in terms of risk definitions, exposure measures, and exposure estimation methods. So exposure is a key ingredient to risk, and because of that, exposure estimation was the focus in our project. So I'm going to be walking you through these 8 steps in the next 10 or so minutes, and then we'll get into a bit more detail on these exposure estimation methods shown here in the green dashed box. So the first thing that you need to figure out is, how do you plan to use the risk values? In other words, where do you want to end up when the process is complete? So we've outlined here 6 of the most common uses, but there's other possibilities for sure. And if you're really ambitious, it may be that you want to use risk values for several of these applications, and that's fine too. But it's important to know where you're headed before you start the trip. And so step 1 is really thinking about how you're going to use the risk values. Step 2 is defining and selecting the geographic scale. And so to define the geographic scales, we looked at past practices in this area of risk assessment. We also looked at other guides and manuals like the Highway Safety Manual, Highway Capacity Manual, to see how these geographic scales were defined. And here's what we came up with: 2 basic categories: facility specific and area wide. So within facility specific, it's useful to differentiate points like specific intersection crossings from segments or continuous stretches of road or street that have similar characteristics. The same thing with area wide. It's useful to differentiate between network and regional scales. So a network is what we consider to be an interconnected set of facilities. It's typically smaller than a city. It's usually a census geography, something like a census block group or a tract, or it could be a traffic analysis zone. Regional scale is typically city size or larger, such as multiple cities in a metropolitan planning area, or it may even be a state. One important point that I want to emphasize is that scale is the granularity of the risk measurement. All right, and so I use the term coverage to mean how far and wide do your risk measurements extend. So it may be that you want to do a segment level analysis, but you want to do that statewide. So in that case, your scale is at the segment level, but you're going to do that for maybe the entire state. In many cases, once you've defined how you plan to use the risk values, you may have also implicitly selected a geographic scale. These are the 6 uses that were the most common uses that I mentioned in step 1. And you can see that the first 2 are typically oriented more toward area-wide applications, where the last 4 tend to be more facility specific, either at intersections or on road or street segments. So once the desired scale is set, a risk definition is selected in step 3. And I'm going to talk briefly about these 3 definitions in the next 3 slides. So observed crash rate, that's our traditional risk definition, and it's most likely to be compatible with other crash analyses and crash analysis tools. However, observed crashes on specific facilities may not accurately represent the true crash probability, especially for shorter time periods. And it's this reason why observed crash rate is preferred more for area-wide analysis, whereby some of those facility-specific issues with observed crashes are fewer. The second definition is expected crashes, which uses statistical models to estimate the true probability of a pedestrian or bicyclist crash. And within these statistical models, one of the key determinants of the probability of a crash is the exposure, as well as other road and traffic variables. So expected crashes overcome some of the issues with observed crashes on specific facilities. However, the advanced statistical models are required to estimate expected crashes. There are some pedestrian and bicyclist models, what's called a safety performance function, being developed now for inclusion in the Highway Safety Manual. But typically, this is not an area that most practitioners are familiar with, at least not yet. The third definition is what we call additional risk indicators or surrogate risk indicators. This is essentially a risk score that combines risk factors into a numeric score or a rating. So as I mentioned earlier, sometimes observed crashes are not the best indicator of risks, especially on specific facilities. So this definition of risk takes that into account by identifying the risk factors, things like exposure and other road and traffic variables that typically lead to crashes without actually developing an advanced statistical model to estimate expected crashes. And this is essentially the concept within systemic safety, identifying those risk factors and improving locations with those risk factors rather than relying only on observed crashes. So if your analysis is facility specific and estimating expected crashes is not feasible, using this risk indicators may be your next best option. So step 4 is selecting exposure measures. There's several different ways to calculate exposure, and selecting the best exposure measure also depends on your desired geographic scale and in some part on the analytic method. That is, can the analytic method that you're using accurately estimate the data that's needed for that exposure measure? I'm showing some example measures here, but I'd like to show in the next slide which puts these measures into context. So we've developed some guidance, this is in the guide, for which the exposure measures work best at which scale, and I'm summarizing that here. And so a basic count, a volume or count-based exposure measure, in some cases it can be the product of non-motorized traffic and motorized traffic. That's typically oriented to specific points like intersection crossings. Distance traveled, that could be pedestrian miles or bicyclist miles traveled. That's very common for segment analysis, especially when comparing segments with different lengths. And this quantity, miles traveled, can easily be aggregated up to other scales like network or region. Time traveled, those would be measures like pedestrian hours or bicyclist hours of travel. They're less common because assumptions have to be made about the travel speeds if you're using the counts. However, time traveled is a great mode neutral measure that helps to make comparisons across different modes, since pedestrian and bike travel have different typical trip lengths, and both modes have shorter trip lengths than most auto trips. The last two measures, trips made and population, those are typically best for area-wide analysis. They're probably my second choice for exposure measures since they don't quantify either the length or the duration of the trips being made. They get at the total quantity of exposure. So the next two steps are selecting and then using an analytic method to estimate exposure. So, you know, in a perfect world of exposure measurement, we would measure everyone that's walking or biking, and we would know exactly when they cross the street, and we would know exactly how much motor vehicle traffic they are exposed to when they cross. And we could measure this continuously 365 days a year for all roads. We could even do this in parking lots and driveway crossings. Unfortunately, we don't live in that perfect world, and so we do lots of sampling and we do lots of estimating. And so we've outlined three basic methods here: site counts, demand estimation models, and travel surveys. The first two methods shown are mostly for facility-specific applications. And in many cases, if you're using a demand model, you're going to need site counts to develop and calibrate that model. The last travel surveys are used for area-wide analysis. Okay, and so this is where we refer back to how we plan to use the risk values, which is step 1. So in other words, if we need exposure on a limited number of facilities, then it's likely that we're going to be able to do that with site counts, and we're going to be able to sample exposure on specific days of the year. I'm going to talk a little bit more about the counts later in the webinar. However, if we're doing network screening and we need to estimate risk everywhere in a city or a region, then we're more likely to do site counts at a limited number of locations and then develop a demand estimation model for all the other places where we can't afford to count. So there are several different ways to estimate bike and pedestrian demand, but one of the simplest and most commonly used methods that we've emphasized in our guide is called a direct demand model. That's the most common. And so it's a regression model that's built by taking a sample of counts and then looking at the land use and the street characteristics around the counts and then developing a model that can then be applied citywide. Essentially, it's sort of like a simplified trip generation model. And so from past efforts, some of the most highly correlated variables are shown here, and I think you kind of see how these might be good predictors of biking and walking activity. And so EPEC is going to go into a little bit more detail on the direct demand models later in the webinar. The third basic approach to estimate exposure is from travel surveys, and there's several possibilities here. There's the National Household Travel Survey, NHTS. The U.S. Census has the American Community Survey, ACS, and then some metropolitan planning organizations also do their own regional travel surveys. But it's important to recognize that these travel surveys can only quantify area-wide exposure. So they don't give you exposure on specific facilities. And so Michael is going to be talking about this approach in more detail later in our webinar, and he's going to tell you about a spreadsheet tool that we've developed that combines the best features of NHTS and ACS, and we do that at the state and MPO levels. So at this point in the process, you've estimated exposure. You may need to compile some of the other required data if you're looking at expected crashes, observed crashes, or other risk indicators. And then the final step is to calculate the risk values based on your particular definition. So I know I've only hit the highlights. We're going to have a little bit more detail, but I wanted to point you to the full guide that has lots more detail. You don't have to write this link down. It should be in our chat pod, or I promise that Google should give you, if you Google on FHWA Scalable Risk Assessment, we're currently at the #1 result. So that should find it for you. We've also produced a synthesis last year. Tamara had mentioned that. That's been available for a while and has some more examples from current use. So with that, I think I'm going to pause. And Dan, did you want to take questions, or we want to do those at the end?
Yeah, thanks, Sean. Let me take a look.
I'm sorry. I'm sorry, Dan. I've got one more slide. I want to mention this as well, some other resources. There's lots of details that we aren't going to be able to cover today. And so if you have in-depth questions, or if maybe you'd like a little bit of technical assistance, we're offering that as part of this project through May of 2020. We also have 3 in-person training sessions that's available for those agencies or regions that are very interested in applying the methods covered in this guide. So just contact me at my email address shown here. Thank you.
Thank you, Sean. And just so everyone knows, I did send out some links just now to the resources that Sean talked about on the previous slide. And I also provided a link. I got a few questions about will the slides be available. We did post them as a PDF on our website, and I just sent, I'll send that around shortly as well. So that hopefully answers those questions. Sean, I've got a couple here. If you don't mind, we can pause and take those. Sure. Question from someone asking, is there a toolkit that would allow me or municipality to make the risk calculations, or is there a database that provides information that we can use to make such calculations?
So the simple answer is it depends. And so again, scale is very important. If you want to, or if you're only interested in estimating at the MPO level or the state level, then yes, the spreadsheet tool that we're going to talk about, again, that combines the NHTS and ACS, but it gives you exposure at a very high level. We don't have a standardized toolkit. Essentially, what we found is the best solution is the direct demand model, and that's really a model that has to be developed for each region. And I know there's several examples of that in the synthesis, and there's a number of regions that are developing their own estimation models at this point.
Great. Thanks for that, Sean. One more here. Asking, when you're using this data-driven approach, how many different risk factors are you considering?
Yeah, so I would say you're considering those that are most important. And so again, depending on the level at which you're doing the risk analysis, what you're probably going to do is you're going to pull the readily available data items that you might have from, say, your roadway inventory. You're going to pull data that you might have locally on land use, but there may be some things that may not be readily available that you may have to collect. Certain items that you may have to go out into the field or use Google Maps or Google Street View to collect. We've got a list of the variables that are most important that we've found and that others have found to be most important for estimating bike and pedestrian exposure. Those are in our guide, but typically you would include as many as you can readily get and use the modeling part to see which variables and how many are really significantly important for including in the model.
Great. That's helpful, Sean. Thank you. And I think we're in a good place now. We can go ahead and move forward with the presentation. I just encourage everyone to continue to send in your comments and your questions, and we still do have some time set at the end for responding to more of those.
Okay, and so I'm going to pick up and do just a few minutes. So for the next 20 or so minutes, I wanted to do a deeper dive on the 3 analytic methods to estimate exposure. And so as I've said, the exposure is a critical part of the risk equation, but it's really been a tough nut to crack, especially for pedestrians and cyclists. So I'm going to talk briefly about counts. EPEC is going to talk about demand models, and Michael is going to talk about travel surveys. So if you're getting exposure from site counts, you're probably going to be limited in terms of the number of segments or facilities that you can cover. Unless that is, you're getting counts, and then you're going to develop a demand estimation model, which EPEC is going to mention shortly. So the thing to know about counts is there are counter technologies that can help you to automate biking and walking counts. I'm going to point you to that guidance on the next slide. Unless you know for certain that you are collecting counts on a perfectly average day or week, it's important to consider adjusting for the day of week or the month of year. Pedestrian and bike counts can be highly variable. Crashes occur around the clock and year-round, so it's important that you have a representative annual estimate when you're using exposure and risk analysis. It's going to be important to balance the number of count locations with the duration. In other words, it may be preferable to have week-long counts at fewer sites than 2-hour counts at many sites. I'd say it's probably more art than science at this point. It's a balancing act based on the equipment that you use, or maybe whether you're even using automated equipment, and the area that you're trying to cover in your risk analysis. Finally, I'm hoping that all this talk about short duration fixed location counters goes away in a few years, thanks to crowdsourced data from GPS mobile devices. I think we're getting close on this, but I don't think we're there quite yet in terms of being able to use it to measure pedestrian and bicyclist exposure everywhere. So we've played a lot of catch up in this area in the past few years, and we've learned a lot about the best practices and how to do pedestrian and bicyclist counts. I'm listing a few of the national documents here, but there's some more recent research papers and articles that really dive into the details on counting bicyclists and pedestrians. So at this point, I'd like to turn it over to EPEC, who's going to talk about demand estimation models.
Thank you, Sean. Hello, everyone. I will now be briefly talking about demand estimation models in the context of exposure estimation. While doing that, I will also provide information on what is presented in the guide in step 5 and step 6 of the process. There are several models that have been or can be used to estimate demand, including, for instance, regional travel demand models, trip generation and flow models, or direct demand models. These models range in complexity and input data requirements. Also, most of these models have an established history or have been applied frequently in various other fields. On the other hand, only few of them have been used extensively in the context of estimating exposure for safety analysis. Next slide, please. Thank you. As Sean described earlier, step 5 is to select an analytic method. There is not really one single best demand estimation methodology that will fit everything. It will depend on several factors such as geographic scale, scope of the analysis, availability of data, or other resources like budget and time. And while you can control some of them, you may not have a choice or control on some others. Next. Keeping this in mind, in step 5, we started by creating a method selection matrix to help make an initial informed choice. The matrix is based on 5 criteria. As I mentioned before, the models range in technical complexity and input data requirements, which we included in the matrix. In addition, you may be interested in learning whether or not they are widely used in practice in this particular field, which was also added as the popularity in practice. We also evaluated the direct usability. While some of these models, and actually most of these models, provide the volume estimate directly, like in the case of direct demand models, some of them must be integrated with other methodologies, as in the case of, for instance, route choice models. And finally, we incorporated the level of accuracy in the matrix. Next, please. Here, I would like to note that we are providing various different information in the guide as part of our informative knowledge map for the selection process. For example, we have provided brief overviews of all these models, including tailored descriptions related to the context and examples from the field. There are also several relevant resources and guidance documents available, and we have documented them in the guide, similar to what we have done for the site counts. Next, please. At this point, you probably know what is important to you, what is feasible, and what you have available. Before you finalize your decisions and move forward to the next step, it is important to pay attention to some key considerations in both model development and application process. First of all, we need to carefully review the project goal or objectives together with the resources available, whether this is time, budget, data, or expertise needs. Second, a model is as good as its input data. Using a very advanced form of modeling might not necessarily give you better results unless it is supported with good data. You may also find out that some models are available for your region because of their use for other purposes. It will be great to identify them, to understand what they have been designed for, how well they perform, and if they will be suitable for your specific use. And finally, the end results of these models will likely include unique characteristics and may not be directly transferable. For almost all models, local customizations will be very important and mostly needed. This actually concludes step 5 for the demand estimation model section, and now we are ready for step 6. Next, please. In step 6, we use the method that we selected in step 5. In an ideal world, as Sean described, we would love to provide detailed guidance on the development of each modeling methodology. However, that was not really feasible. Therefore, we focused our attention to direct demand models, which are the most widely used tools for pedestrian and bicyclist volume estimation. Next. Direct demand models have been primarily used to develop facility-specific demand estimations. They are appealing due to their simplicity and convenience, and since they are generally based on available data. These models, as Sean described, are statistical models, and they are often based on regression analysis. They are developed using different data sources such as population and employment measures or land use and transportation network characteristics. The model variables show some differences based on the mode, whether it is a pedestrian model or a bicycle model, and they are really very much dependent on the local context. And just to give you an idea, several of the studies that we have reviewed during this study indicated the important role of density, accessibility, proximity on pedestrian models. In addition to such similar neighborhood forms, infrastructure and system characteristics were also important, especially for bicycle models, such as presence of bicycle lanes and traffic volume. It's also important to note that these models are not without limitations. For instance, they are limited in capturing the behavioral structure, and they are usually not transferable due to their strong linkage to local context. Therefore, as I mentioned earlier, the purpose of your analysis is a key element to explore whether or not these models will be of help to your specific case. Next slide, please. The generalized approach to develop these models, or really any model will be, includes three primary phases: identifying the focus of the study, preparing the data needed for the model, and developing the model. And then we can use the model results to estimate volumes at locations where the count data are not available. At this point, I would like to reemphasize that a model is as good as its input data. For instance, if you are trying to estimate demand at different facility types across your entire area, you need to have representative sample of site counts to be used as your main variable of interest, and we call this as dependent variable of your model, not just the worst crash locations or busiest sites. For the guide, indeed, we walk you through each of these details. We developed a framework based on these main phases and provided very detailed step-by-step instructions describing the tasks involved in each of them to develop a direct demand model. Next. And finally, we try to make it more practical and relevant to the reader of the guide, to you, by presenting several example studies that have developed and applied these models for exposure estimation in the safety field. While some of them include detailed explanations that we try to match to the instructions, step-by-step instructions that we provided in the guide, for many others, we have included a table of information on the key characteristics so that we could present different procedures during the development stage. With this, I'm concluding the demand estimation models section, and I would like to turn it over to Michael, who will talk about travel surveys. Thank you.
Thank you, Ipek. Hi, everybody. This is Michael Martin. I'm going to cover these three typical travel surveys that you'll find. I'll start out with the American Community Survey, or also known as the ACS. I'll also talk about the National Household Travel Survey, which is commonly referred to as the NHTS, and then I'll end with the Regional Household Travel Survey. Travel surveys are a systematic effort to collect information about individuals' travel behavior. They are typically based on statistical samples of travels within a certain area, and those individuals are directed to record their travel events on specified days or set of days. And those pieces of information are used to represent an average day, typically a weekday, but they can also be used for weekends as well. Some of the information that's collected here is travel mode, trip purpose, start and end locations, and trip length and duration. And this information can be summarized typically into aggregated geographic zones, and as Sean pointed out earlier, not to specific facilities. So here, getting a little bit more in depth with, let me go back. Ooh. There we go. Sorry, back to the ACS here. It is a national ongoing survey of a survey sample of the U.S. households. It's conducted by the U.S. Census Bureau. It gathers a variety of information in addition to travel of that sample. It collects demographic, social, economic, and housing information. The question that it asks for about travel is the primary travel mode from home to work. So no non-commute trips are collected using the ACS. The ACS data is provided in year estimates, which are provided for 1, 3, and 5 year set of estimates. The 3 and 5 are larger samples, and so they are better for larger areas relative to 1 year estimates. 1 year estimates, since they're a smaller sample, they're beneficial for larger populations, for MSAs or states. So here we're looking at the NHTS, the National Household Travel Survey. This is a national ongoing survey that looks at daily and long distance travel that is conducted every 5 to 7 years from a sample of U.S. households. This survey is conducted by the U.S. DOT and also the Federal Highway Administration. The information it contains is all trips. So it contains a travel diary where the participants record every trip that they make for a specified day. It also collects household characteristics, person demographics, and vehicle details along with that travel information. The data availability is typically these surveys, as I said, are conducted every 5 to 7 years, and this has been done since 1969. And some of the data are actually, more data is available for certain areas, specific areas, because they've participated in the add-on program with this survey, to where they can actually purchase more samples and also specify specific questions to be asked. So here, the final travel survey that I'm going to cover is a regional household travel survey. This is very similar to the NHTS. It is typically conducted by an MPO, or Metropolitan Planning Organization. So these surveys are much more tailored to a specific geography or a certain area, like an MPO. They're typically done to provide inputs in a regional travel demand forecasting model. And as I said, the data are very similar to NHTS, but here the questions can be more easily tailored to specific needs or interests of a local area. Data availability, these are conducted between about every 8 to 10 years, depending on the MPO or the regional planning organization. The GPS data can also actually be collected along with this data via smartphone apps. This is kind of a more common, or it's becoming more common with these regional household travel surveys. So with these three, there are a lot of nuances that set each of them apart from one another. The frequency, geography, the questions that are asked, the sample sizes that they are based upon, and the availability of data really dictates or directs how these different data sources can actually be applied to projects like estimating exposure. And so they're not created equal, and that's something we wanted to point out here in this exercise or in this webinar. So moving on to the Area-Wide Non-Motorized Exposure Tool, which is based upon the ACS and NHTS data. This tool was developed to make it easy for practitioners and people out in the field to estimate non-motorized exposure to risk at different geographic scales. And as Sean and others have pointed out, the scale is very important based on the application that you're applying this. And the two scales that we're going to focus on are the state and MPO. This tool is used to estimate annual exposure for walking and biking. It can also, it provides a combined estimate as well. And the three forms of exposure are trips, miles of travel, and hours of travel. In addition to those exposure estimates, total fatalities are also included, and those were drawn from the National Highway Traffic Safety Administration, also known as NHTSA, their fatality analysis reporting system known as FARS. We used the person data to pull out total fatalities, and that was used in addition or in combination with our hours of travel to produce a risk estimate. So risk in this tool is fatalities per hours of travel. So as I said, the two scales that we're going to focus on here are statewide and the Metropolitan Planning Organization, or the MPO. The statewide uses the 2009 NHTS travel characteristics to estimate exposure at the state level. And it also uses ACS one-year estimates to fill the gaps between when the NHTS survey is conducted. Because those are conducted not on a very frequent basis, we have to supplement the NHTS travel characteristics with more current information that can be drawn from the ACS one-year estimate to bring the estimates more current for each individual year. So for the MPO, we also draw upon the 2009 NHTS travel characteristics and use those estimates that are located in CBSAs, which are core-based statistical areas, as proxies for MPOs. Because the NHTS does not have samples in every MPO throughout the US, we have to use, we created a set of peer groups to where we could actually transfer similar travel characteristics or travel characteristics between similar MPOs throughout the US. So in addition to the 2009 NHTS, similar to the statewide, we used ACS 5-year estimates to interpolate up to the MPOs. Some of the inputs for this tool needed, for instance, population estimates within MPOs. And so using a smaller geography that could be interpolated up to a geography that's not represented in census data was done here using ACS 5-year estimates. So going on to look at the statewide non-motorized exposure element of this tool, this estimates walking and biking exposure at the state level for individual years between 2009 and 2016. Again, this is based on annual ACS commute trips that were adjusted for changes in populations throughout those years, and also expanded to the NHTS based upon the relationships between the commute and total trips. So here, this is the screenshot of what the tool actually looks like. It's quite busy, but hopefully I can break it down and make it a little bit more easily understandable. We break this up into 3 major parts. So we have walking, bicycling, and the combination of non-motorized exposure. So at the very top up here, to the left-hand corner, the user can actually select the state. And so here we have New York State selected. And dropping down just below that, you can actually see some of the inputs that are fed into this tool. Those include daily persons commuting, commute to total trips adjustment factor, and population adjustment factor. And so the other input here is the average trip length. And what I'm highlighting is that there's a default value. But since this is a tool that is using data from, let's say, not the most current data in some instances, we offered the opportunity for the user to input their own value if they have a better estimate. So here the user could actually hard input their average trip length in terms of miles straight into the tool to get a better estimate. So as I said before, the 3 exposure measures that come out of this tool is the estimated annual trips. Here it's for pedestrians, estimated annual miles of travel, and estimated annual hours of travel. And just below that are the total fatalities, and then the risk estimate, which is the fatalities divided by 1,000,000 hours of travel. So to take that spreadsheet and to make it to where it's a little bit easier to interpret and to also see trends, we provided some graphics that are located just below the fields that I just showed you. And so it's the first column here, you can see each of the exposure measures on top of one another per mode. And so you can easily compare how trips and miles of travel and hours of travel differ for the same mode. The next column actually looks at similar or the same data, but just in a different way. You're actually looking at bar charts of the modal proportion per exposure measure. And so you can see that walking and bicycling make up each one of these exposure measures in a different way. And so the proportions are shown in bar charts there for each year. And the last column here is the annual fatalities and the annual risk, so that you can easily see how risk changes over time. So moving on now to the MPO non-motorized exposure element of the tool. This also estimates walking and biking exposure at the MPO level for the same set of years, which is 2009 to 2016. It uses 2009 NHTS trips that were adjusted to represent the analysis year out of that set of years. They were adjusted to reflect changes in commute trip making between 2009 and the analysis year of interest. And so here, this is how that tool would look in the spreadsheet. It's very similar to the statewide one. It's set up slightly different based on how we had to use the different NHTS and ACS values. So at the very top left corner, the user can select the state to narrow down the list of MPOs. And so from that, the next selection here, you can select a specific MPO throughout the U.S. So here we have Oregon and the Portland Area Comprehensive Transportation System. And so down below that, we also have the same or a similar set of inputs here. They are going to be different from the statewide due to data availability. But here we have the NHTS person trip rate, the MPO population estimate that was interpolated from ACS data up to the MPO geography, and then also the population adjustment factor between the changes between 2009 and the analysis here. So similar to the state, we estimate annual trips, annual miles of travel, and annual hours of travel, and also provide the number of fatalities and also the same risk estimate here with fatalities divided by million hours of travel. Dan, that concludes my part with the travel surveys. I know that we're moving on to Robert's case study next, but would you like to take any questions at this point?
Yeah, there are a couple that seem to fit right here. A few that are related to the ACS data. So I wonder if we can talk about that for a moment. Several questions asking about whether it's feasible or whether people are capable of taking into account seasonality when using ACS data. Since that information, it sounds like, is collected just at a certain time of year, is it possible to take that into account when using ACS data?
With the publicly available ACS data, I'm going to say no, because they do come out as annual estimates. And I'm couching it that way because, you know, the ACS, it's an ongoing survey, so they're collecting samples all throughout the year. But what's available to the public, I think, would preclude you from being able to take into account seasonality, you know, differences between seasons.
Okay. Beyond the ACS data, some more questions about whether or not you all can recommend some best practices or sources for general adjustment methods regarding counts that are happening at various months throughout the year. Should practitioners in this case just mainly use their judgment based on where they're located, or are there some good resources out there to help them understand which adjustment factors to use?
Yes, so this is Sean, and I think that's referring to the count adjustment. So typically when you're doing counts, unless you have a permanent counter installed, you're putting a counter out for a much shorter period of time. And so I mentioned that annualization. So that the seasonality varies somewhat. The FHWA's traffic monitoring guide, and there's a few other resources, tell you how to do that if you have permanent counters already. But there's been several other research papers from different places that have showed the seasonality in different regions of the country, that if you don't have local permanent counters, you might be able to use some of these regional averages from some of these other research studies.
Okay, that's very helpful. Thank you. And if I can do it once we shift on to the rest of the presentation, I'll try to drop some links to the traffic monitoring guide and some other NCHRP resources on accounting and volume data collection with some adjustment factors that might be of use in this case. I'm wondering, and one more question before we move on, does the guide cover smaller area-wide scales that are citywide and corridor scale? Sean, I think you got to some of this at the beginning, but can you remind us various scales that are described?
Yes, it does. And so there's 4 scales that we talk about. And again, scale is the granularity that you're trying to measure risk. And so the methods that we talk about range all the way from point-based scale, which is maybe it's an individual crosswalk or a crossing at an intersection or mid-block crossing. So that is the first scale. The second scale is segment. That's typically, that's sometimes what we look at in motor vehicle analysis. That's a common unit of analysis. Network is where obviously you have a network of interconnected streets or roads. And then region is the 4th scale. That's the largest. We're typically in that region or that scale, we're talking about MPO areas, maybe citywide or even statewide. And so we address all 4 of those scales using the different methods that we've just talked about.
Okay. Wonderful. I did get one more question on the NHTS and ACS data that I wanted to ask before we move on, and that is question, is there a way to limit exposure estimates derived from NHTS and ACS to just look at rural areas? Is this possible?
I think it's a good question. The reason, the tricky part about NHTS is knowing where your samples are located. And the publicly available data does not provide a lot of information to tell you where a person was located when they took the survey. We were able to come up with peer groups because they do provide core-based statistical areas names in the data. And so those are very similar in size to MPOs, and that's why we were able to transfer the NHTS estimates to those particular areas. For the rural estimates, they do tell you if it's urban or rural, but you know, where in the rural area. It all depends on how small of an estimate, how far down you want to get in a rural area. So yes, but it can be tricky.
Got it. Yeah, thank you. That's great. I think we can safely move on now. I am getting some more questions, but I think we should plow ahead, and then we can have some more time in a moment to talk through them.
Okay, this is Robert Hampshire here at the University of Michigan. I'm going to describe a case study that the University of Michigan partnered with the Michigan Department of Transportation with the goal of developing a risk assessment tool for pedestrians for all 83 counties throughout the state. MDOT's goal was to create a risk score based on mapping crashes and risk characteristics, not just observed crashes, for a defined area network for the entire state of Michigan. So this will be network-based, but the scale is over the whole state of Michigan. And I'm going to present what I call like a fictional case study or a use case based on this project. And I want to thank the engineers at MDOT for motivating this example. Next slide, please. So this case study focuses on pedestrian risk assessment to identify corridors throughout Detroit, Michigan in need of countermeasures. Often the characteristics that make walking safe or unsafe persist over space. For example, along busy roads, or land use features like business districts or lack of lighting are often consistent over space. So due to this spatial continuity, the transportation engineers often like to improve facilities in the entire corridor, not just one location. Next slide. So what I'll do is briefly review and go over the 8 steps as they apply to this project. So step 1 in determining the use of risk values. The MDOT engineers, again, are interested in estimating pedestrian risk to identify corridors in need of countermeasures. So that corresponds to network screening, area-based. Step 2, for the geographic scale, the team was interested in analyzing the risk at the corridor level. So again, that corresponds to area-wide, network, and then we say here corridor. For step 3 is to select the risk definition. So what we're going to use here is expected crashes. So our definition of risk is going to be an expected value of the number of pedestrian vehicle crashes, and we're going to have you'll see a model that includes many different risk factors. And step 4, for the exposure measure, we're using trips made. So the project team measured exposure in terms of trips per day in a unit of analysis that we're calling a pedestrian analysis zone. And that's roughly a 400 meter by 400 meter area. And so these areas are going to be used to do the corridor analysis. And you'll see that on a couple slides, we have some images. And also there's this is the live tool that has a website and it's interactive that's there on the 2 slides ago. The URL is there. So that's available for you to visit now. Next slide, please. For step 5, this is the analytic method we're using for exposure. So we're going to use a trip generation and flow models. And I'll give you a little bit more detail on that in a couple slides. But this analytic method uses a travel survey, a statewide travel survey, in addition to other factors like land use data, household characteristics, and so forth. In step 6, what we actually do to actually estimate the model is going to be a series of regression models. I won't go into too much detail about that, but I will give you a little bit more granularity about the methods here in a couple slides. Step 7, of course, this method requires other data to compile the risk score. So mainly we have crash data from the Michigan Traffic Crash Facts database. So we have all the crashes. And we also have detailed information about roadway characteristics that we're going to use. That's road widths, AADT, the road volumes, and so forth. And finally, we put that together being inspired by the Highway Safety Manual. We compute the risk score using the empirical Bayes perspective and a specific pedestrian safety performance function. So I'll say a little bit more about that in the next slide. So next slide, please. So here's a high level model of the analytic method. I'll just say a few things about it. So this analytic method used inputs from a statewide travel survey in addition to some ACS data. We use as inputs land use data and household characteristics. The key outputs of the model are an estimate of the number of crashes, pedestrian crashes at this pedestrian analysis zone. And also the output is the risk score. To achieve these outputs, we had to estimate a walk production and walk destination model. These are regression estimates that convert the input into the trip production and destination counts. I won't go into detail about it, but we borrow heavily and are indebted to Dr. Clifton at Portland State and her colleagues for this model of pedestrian demand. Next slide. Here's a sample output of the tool that you'll see. It's an interactive tool. So the project, like I mentioned, the project team used household travel survey to fit our production and destination models. And in those models, we divided the trips into categories that are typical when you think about trip demand models. So we have home-based trips, non-home-based trips, home-based trips that are related to school, non-home-based trips, and non-home-based trips that are related to work. So for each of those categories, we estimate exposure. So the picture you see now is the resulting pedestrian exposure estimates for Wayne County in Michigan. That's where Detroit is. And the unit of analysis here for the exposure, remember, trips made per day per PAZ. So each of those grid points is a analysis zone. Next slide. For step 7, to compute the risk value, we had to use other data, supplemental data. So this approach required many other data sources to calculate the risk values, particularly the built environment variables and travel characteristics are key inputs into the exposure. These are combined with roadway characteristics and crash data to calculate the risk score. This is done using the empirical Bayes method by developing a safety performance function. So we estimated our safety performance function for the whole state and for, in this case, the Wayne County in Michigan. I won't go into the details of the form of that safety performance function, but it's available in the report. Next slide, please. And so here's the risk score for step 8. The MDOT engineers wanted to analyze corridors, as I mentioned. So thus we applied something called level of service of safety metric. This is from the Highway Safety Manual. The level of service safety divides the risk score of candidate areas into 4 categories based on the standard deviation from the average risk score. So we computed the risk score for every one of these PAZs, and then we calculated these 4 categories based on the standard deviation from the average risk score. The areas in the highest quantile we consider the most dangerous. So those appear there in the red. So we are interested in 2 main corridors throughout Detroit. One is called Woodward Corridor, and the other one is called Gratiot Corridor. So we can take our risk score and aggregate it up throughout that corridor to get a final value. So the Woodward Corridor risk turned out to be 91, and the way you think about it is expected crashes. And for the Gratiot Corridor, the risk score was 50. So in this analysis, it appears that the Woodward Corridor is more risky for pedestrians. Next slide. So here are some of the lessons learned. A couple things is that the trip generation and flow models that we used actually require a significant amount of technical capability to execute. Also, the Highway Safety Manual provides an analytic roadmap for non-motorized risk assessment, namely the empirical Bayes perspective. However, developing and validating pedestrian-specific safety performance functions can be challenging. Also, in order for these methods, this risk score approach to be effectively implemented, it must be integrated into the organization's workflow and processes. So a key takeaway for this project and this case example is that while we can do these this great risk score and risk assessment, it also needs to be, like I said, integrated into the standard financing processes and project selection processes. So finally, I like to say that the guide contains throughout many examples and calculations of various scenarios throughout the guide. So there's some hands-on examples that be quite useful to you. And what I presented here is just one of the larger case studies that are also in the guide. So that concludes my discussion of the case study.
Thank you. Robert, if you have a moment, thanks so much for that. I think it's a great example to illustrate how this can be used. A few questions for you about, you made reference to a tool that was used in this example. I think that is a different tool than the Excel tool that I shared from Sean a bit earlier. Is the tool that you're describing something that I can share with the group, or is it available?
Yes, it's there on the first slide of the case study.
Let me, when we get into the Q&A, let me see if I can just drop that link in to the chat pod here and send it out to everybody so that we can all have it. Oh, there it is, the link at the bottom. If you wouldn't mind holding that slide just for a moment there, I think that would be good, because I do have a couple of other questions while we're here with you, okay. And I'd like to go ahead and send them over your way. The question about the measure of the expected crashes in some of the material you shared, yes. And the question about that in particular was, are these normalized or controlled based on roadway length, corridor length for a certain corridor? I think we're familiar with expected crashes for maybe an intersection, but I'm wondering about for the corridor length. Does that come into play?
Yeah, so it has takes into account the length of the road segments along with the average annual daily travel along those segments.
Okay, great. Thank you for that. While you were answering that, it gave me enough time to generate the link to the tool that I will now send out to everybody in the group, so we'll all have that. And I'll try to remember to add that to our archive page as well, so that you can take a look. And I think, Sean, correct me if I'm wrong, we are ready to go into our full discussion period now?
Yes, we are.
Okay.
General question and answer.
Thank you so much. And what I'm going to do while we migrate here, I'm going to pull up a slide that includes contact information for all of our panelists, because I know that you may have questions that you want to ask them specifically, and don't hesitate to reach out and ask those questions, because I think there may be things that you want to follow up with these individuals about. But while we have time, I'd like to go through some of the questions that we received, as many of them as we can get through. And one of them really caught my eye, and it was a question about how we can use this information, some of the risk information that we have collected as part of this process within a road safety audit process. So let me actually read the question. Do you think it would be beneficial to build the review of the roadway via these risk factors that you've outlined into your road safety audit process? Since typically you have people with various perspectives in attendance at a road safety audit to offer up appropriate feedback and kind of maybe use that as a sounding board for what you're learning. I'd be curious if any of you all have reaction to that.
Yes, this is Sean. I think absolutely. So one of the risk definitions is going through and looking at those risk indicators, and certainly those risk indicators or those risk factors, you know, those are commonly poor design, or those are roadway or street designs that we know aren't conducive to biking and walking, and I think that's typically what's covered in a road safety audit. So absolutely.
Okay, perfect. Any other comments on that question in particular? Just want to make sure. So another question came up. There's a bit more technical about the spreadsheet tool. So maybe Sean, you can help with this. A question about within the spreadsheet tool, it looks like the measure of fatalities per million hours of bicycle and pedestrian travel was used, as opposed to, this person speculates, why weren't we using fatalities per million miles of bicycle or pedestrian travel, which maybe seems more logical to some. But can you talk about maybe the differences between those two measures and why you went with hours of travel?
Yeah, so this is Sean. So, and I've got Michael here too, in case it gets any more technical. But we have both miles and hours in the spreadsheet. We simply show hours of travel in some of the charts because of what I mentioned earlier. Hours of travel is typically a more mode neutral measure. If you prefer VMT or BMT or PMT, it's there, it's available. We just think that hours of travel is more mode neutral, and if you would like, and if you're interested, you can compare the risk of walking modes with biking modes with motor vehicle modes. Again, recognizing that these are all estimates of travel.
Got it. All right. I'm wondering, a few questions came in. I'm going to see if I can collapse these into a more general question for you all on this topic. Is the risk factor, the risk information that you can develop as part of this guidance and the methodology that you all put forth, is there anything in here that can help us capture any pedestrian or bicyclist behavior that we can, maybe something that we could observe behavior-wise through a road safety audit or field observation? Is there an ability or an application for us to incorporate behaviors into the risk data that we're producing as part of this? Or is this a bit more strict in terms of quantitative variables that we can see and measure that you've described? Anyone?
Yeah, this is Sean. I'll take a first stab at it, but because EPEC said the word behavioral models, I may also ask her to add something if she'd like. So typically, Dan, you're right. The risk definitions use quantitative variables to get at risk rather than actual behaviors. And so whenever we pick up crashes or expected crashes, those are the results of those behaviors, but we're not necessarily measuring those behaviors everywhere because just honestly, those behaviors are much more difficult to measure than exposure. But it may be that if you're focused on a certain area, that risk may only tell you a certain bit, and you may actually need to look at behavior to understand why things are the way they are at certain locations.
This is Ipek. I very much agree on what Sean indicated and can mention a few other things. So we actually incorporated in the guide, as we described in the presentation, various different demand estimation tools, including the ones that will be taking into account the behavior. In step 5 especially. In step 6, we focus on direct demand models, and direct demand models do not really take into account the behavior. That's actually one of the limitations. They are directly explaining the level of activity at a given location through an association with various measures of the local environment. So if we would like to take into account the behavior, which will be very important, especially at particular cases, then I would recommend to think on some other methodologies. For instance, what has been described in the case study, trip generation and flow models. Within those models, we can actually incorporate behavior models that will take into account that aspect of the risk.
Okay, that's very helpful. Thank you for weighing in on that question. I think it's an interesting one to think about how behaviors can kind of interrelate with some of these metrics that we're talking about. So I appreciate you weighing in. There is a question for Robert about the Michigan example that you provided, and the question is, what was the source in that example for estimating pedestrian exposure or walking trips, and would this method work if the sidewalk data was not available? Robert, what do you think about that?
Yeah, so the source of the main source was a statewide travel survey called MI Counts. So that was the main, sort of household trip diary level state survey. And there, as far as sidewalks go, we did not have a complete source of sidewalks for the entire state. Some cities throughout the state we did have sidewalks for, but not for the entire state.
Okay, great. Thank you for clarifying that. I wanted to ask you all if, or maybe speculate, because this is a fairly new resource, and I don't know how widely it's been used yet, but there's speculation in the crowd about, or the question of whether agencies can begin to use tools like this to include measuring risk as among their potential safety targets for maybe performance measurement. So I think currently a lot of MPOs, for example, are establishing safety performance targets among their many measures that they're using that usually rely on crashes, measures of crashes in some way, rather than risk. And I wonder if you all think that maybe we can move toward agencies setting targets and goals for risk levels instead. It seems to be a bit more proactive of an approach, but I wonder if you're aware of agencies that are doing this, or if you see that being maybe coming down the line.
This is Sean. So I'm not aware of many agencies that are doing that, but that was one of the goals of this project, was to really address the safety performance measures question, and especially do that for non-motorized modes. And so that is where the spreadsheet tool that we talked about during the webinar comes in. We tried to make that spreadsheet tool as easy as possible, so that folks, all they need to do is go in, select their state and MPO. And what we're doing is we're pulling up what we think is the best estimate of total non-motorized activity. Now, that's what we developed. To go beyond that, to go beyond performance measures, right? So if you're tracking performance measures and you see your measure got worse, well, why did it get worse? You're going to need to have more information. But again, I think given where we are in terms of performance measurement, we think that having this information just at a state or MPO level is going to be helpful to some folks.
Yeah, that's really helpful. I do see that as being something that agencies want to move toward, but I think the missing piece has maybe been to have some really good, reliable way of establishing what that risk target might be. So I think that this is really helping fill that gap from my perspective. So thanks for talking about that a little bit, Sean. A question about near misses or almost near crashes and conflicts, and whether or not the near miss is incorporated into the guide in any way, and thinking about, I guess, some agencies who are trying to do a better job of collecting information or data about near misses. I've seen some examples of agencies that are using video data to look at conflicts, say at intersections, and with those types of data, could that be incorporated? Does the guide allow for this type of near miss data to be incorporated into the risk models in some way? I'm interested to hear your perspective on that.
Yeah, so we didn't address near misses. That was really beyond the scope of what we were dealing with. We're mostly focusing on either observed or expected crashes. I think that is a very interesting question. And as we think about how we analyze safety in the future, and as we think about all these gadgets that are in everybody's hands, or all these gadgets that are installed at street corners, think about about the increased possibility of being able to measure near misses or conflicts. But I think one of the other questions that's out there in the safety community is, are near misses really aligned with safety? In other words, do a place where you have a lot of real misses or very few near misses correlate to places with high or low safety? I think that's still something that the safety community is looking at as we really get access to some of these, get the ability to collect near miss data.
Yeah, no, that's really interesting. I think that there's some interesting work being done, like you mentioned, on this topic, and I think it's hard to tackle it all with one project. But I think that there is some real value in assessing risk, even beyond what we have, what we know about near misses, and maybe using those in collaboration with one another could be interesting. Possibly down the road, we'll have to talk to TRB friends about that. I wanted to ask a question about. There are a few questions that came in. People are really interested in measuring or predicting, I guess maybe modeling, an increase in bicycling and walking as a result of safety improvements being made. I know that this is maybe a bit outside the scope of this project, but I'm thinking about it in terms of, if you can show with the safety improvement maybe a reduction in risk, is there also a way to measure or predict how many more people might bike or walk in that area? Would anyone care to take a stab at that one? Any good guidance out there on this question?
Yes, I'll start first and let others speak up. So that is one of our 6 most common uses that I mentioned in step 1 as a before and after. I mean, that's a very common thing to be able to want to quantify not only the safety change, but the activity change, because often these improvements generate more biking and walking, but we need to account for that somehow when we're evaluating the effectiveness of these improvements. So yes, that is included. That's one of the common uses for risk values.
Okay, great.
And this is Ipek. I can just comment very briefly. So from a prediction or the modeling perspective, direct math models can provide some quick estimates or screening to evaluate those kind of conditions. And if we are trying to understand more in terms of, for instance, how the facility is helping, or how the new traffic calming strategies are helping, we may actually need to consult more with the behavior models, because these are actually inducing behavior. They are really impacting the behavior. But as long as there's one variable in the direct math model that can be related to that implementation, we can have a quick estimate from these models by using that variable.
Thank you very much. The next question I had is, it gets to Robert, back to your example, and we see a lot of value in assigning and developing these risk models and understanding pedestrian bicyclist risk. And the next question for an agency, maybe like the folks at Michigan DOT that you worked with was, okay, how can we then go from understanding risk to deciding what countermeasures and what on-the-ground changes we can make? I guess my question for you is, what do you see as sort of the next step beyond the risk assessment for an agency that's interested in countermeasure selection? Is there very clear connections between the types of risk and what we might decide to do in terms of countermeasure treatment?
Yeah, so part of the project was a follow-on could be just a prioritization. So if you have the data of the now state of risk, and maybe you can prioritize areas, then at least you can get a prioritized list of locations. I think countermeasure selection is, from my standpoint, a separate aspect that's not part of this project. But at least with this approach, you can prioritize the areas.
Okay, great.
Yeah.
And that may be an opportunity, like we mentioned earlier, the connections between maybe a road safety audit to do some further diagnosis that puts you on the path toward countermeasure selection. I wonder, the Texas A&M group, any comments on the countermeasure selection, maybe as a step beyond the risk assessment that you can conduct as part of this guide, or recommendations for agencies who kind of want to take it to that next step?
No, that's right on, is that it's really beyond what we've presented here about risk assessment. And so once you understand the different levels of risk, you really need to understand what is causing that as a way to say, okay, what do we specifically need to improve? In certain cases, though, like for example, that if you're using the additional risk indicators where you've identified those risk factors, you might already know the risk factors that scored highest at a particular location that need to be improved at that particular location.
Great, thank you very much. I have a final question, and I didn't warn the panel that I was going to bring autonomous vehicles into the discussion, so forgive me, but we got a couple of questions about this, and I can't resist asking, because some of you in your, I see in your past work, you're interested in emerging technologies and mobility. So I'll ask, how do you see the rising number of, or the potential for autonomous vehicles impacting not only the way safety improvements are done, but these types of risk assessments? If we're changing vehicles and how they operate and how they work, is this going to impact the sort of risk assessments we perform? And this is total speculation on your part. I understand that this was not included among your research tasks, I'm sure. Anyone care to take a stab at that one?
Yeah, this is Sean. I'll look in my crystal ball, but also let others. So someone asked about near misses earlier. I think that's very interesting. And as more and more cars drive around with pedestrian or hazard warning systems, these cars are going to be detecting these near misses with pedestrians or cyclists. There's a commercially available product right now that we've tested on transit buses that essentially does that. And so, what I see in the future is I see the ability to gather a lot more granular near miss information as well as exposure information.
Okay, that's great. That's very interesting. We'll have to wait for that project to complete, maybe several years into the future. But I appreciate you weighing in on that and tackling all these questions. I think the guide is wonderful. I think you all should, if you haven't, take a look, use those tools that Sean and his team and under Tamara's guidance have developed, and let them know what you think. Sean's email address is here. Sean did mention some opportunity for maybe training and technical assistance moving forward, I think, Sean. So please reach out to him and his team if you're interested in following up on any of that. I'm sorry to say that we don't have time for any more questions today. I'll encourage you to reach out to our panelists if you have questions for them. We have an email coming to you later today that'll include a lot of information, links to the resources we talked about, how to download the slides from today's webinar, the certificate of attendance, which will be very important for a lot of you. That'll all be in the email. It'll come in about an hour. And I want you to consider, as you leave today, answering some questions in the brief survey that will pop up as you leave the webinar. We'd appreciate your feedback, ideas maybe on future topics that we can tackle in these webinars. We have a few more sessions coming up later this month, so I hope you'll consider signing up for those. I just want to say thank you again to our entire panel for delivering today's webinar and for their work developing these resources for us. And thanks to all of you for attending the session today, and we hope to see you next time. Thank you very much.
Thank you.